All right, I'll get rolling. So welcome to webinar 3. So we've spent quite a bit of time now going through the climate models and the map sets. Today we're going to look at how to use the tool and maps for range management planning and linking the forage resource and looking at how to calculate the forage resource based on the predicted zones of use. And then also we'll discuss a few of the potential uses of the mapping resources. So we'll probably spend the majority of the time kind of looking at calculating carrying capacity, but that's gonna lead into the process for planning water developments and for planning locations for rangeland health assessments. And this information can also be used for identifying potential conflict areas, I guess, if you want to call them that, where there's cut block grazing or private land issues or species at risk, winter ungulate ranges, recreation, and those types of things, how the visual maps can be used to sort of assess those other uses on the landscape. Are there any questions from last webinar right up front? I can hold off for a little bit here, or we can have those questions at the end as well. We're also going to end today's webinar with how the different ways of accessing the maps and how to go about using, how you would use the maps in a GIS interface or within a PDF map or Venza on your handheld for in the field. I'll just assume that there's no questions right now. We'll keep going. So we'll also look. So we're going to look at we already looked at this climate model and the flow accumulation model, but we're going to spend more time on these forage categories. And part of the reason to look at the forage categories is that it can be used for planning water developments, and that was kind of the purpose of the caribou pilot projects that we'll look at in webinar 4. It was using this tool for planning the best locations for water developments, and we did this by really focusing on linking the forage resource and the water resource. So when we're looking at range management planning and when we're considering the aspects or the things that go into range management planning, what we generally try to focus on are the constraints to livestock grazing on the landscape. So what is limiting the use of the landscape? If we just had a flat level landscape of one type of forage and water in the center, we have very few limitations to grazing. But within our complex sort of landscapes that we have associated with BC range, there are a lot of constraints, and we need to sort of identify the resources, but then also identify the constraints, and then we can use that information to determine how much forage is within these zones of use. And we can also use this information to potentially identify areas where forage could be developed or improved, or where water could be improved. If we have an area on the landscape where we have a large amount of forage but no water, we can potentially look at that zone for developing some water to access that forage resource. Planning rangeland health assessments. If we have predicted zones of use within our range unit, so we use these buffer layers to predict our zones of use, and if we can identify where the livestock are most likely to occur, we can focus our rangeland health assessments on those areas, as opposed to just having a large range unit with unknown rangeland health. We can use these zones of use to locate our rangeland health assessments. So we would go to where our predicted zones of use are, and that's where our rangeland health assessments could be done. And that will better capture what the impacts of livestock grazing are on the landscape, or to establish kind of a baseline health of what is on the range unit, as well as if we're doing clipping studies or trying to determine forage production studies, we can use these maps to identify those locations where livestock aren't likely to be grazing, and then that's where we can clip for our productivity. If we know that livestock haven't been using that area, then we get a better understanding of how much grass is potentially can grow in some of these regions. And so, you know, understanding where the livestock are in the landscape can kind of help with both aspects, whether it's determining where livestock are or where they aren't. Going back to webinar 2, we looked at these. These were 2 of the maps that we had looked at, and the Forage Resource is a map that identifies the different range types that are on the landscape, and our water resource map identifies the potential areas that livestock are going to use, or the ponds that are resilient versus those that are not resilient. So these are the two maps, as well as a slope map that we'll spend most of the time on today. And we also went through we have the base map, so that's based on pond size. We have our potential zones of use that is specific to the pond size, but then also we have to recognize that we need to verify this map and put on the true water resources that are accessible. So if we have our original modeled map, then we're going to move to this map that I guess I'm calling verify the map, using the flow accumulation. So that concept of identifying which ponds are connected based on the flow accumulation, and also based on knowledge from the range manager or the range tenure holder. And then we have the true areas that the livestock are using for water developments, or for watering. And then we put the buffers on top of that to acknowledge that there's other water resources out there that are beyond what our model can identify. And so then this would be a starting point for a map, is not just the model, but then also verified off of range manager experiences. So for the forage resource, you know, most of the time we spent so far is looking at the water resource, but we're going to spend some time now on the forage resource and reviewing these maps and identifying the different forage resources, the primary range, or the estimates of the amount of forage on the landscape, and then identify where that forage resource is not connected to reliable water, and how do we calculate that forage resource within those areas, comparing the forage resource in future versus current climates. And then this, again, just to emphasize, determine if and where there's potential to develop a forage resource. And I'll talk a little bit, how do we estimate these forage values, and most of it's going to be based on range types or through actual destructive sampling. And we'll go through a little bit of what both that means. So the overall definition, what we kind of want, what we want to accomplish is we want to determine how much forage is available for livestock, and basically this is what the animals that are on the land base will actually consume based on the type of plants, based on limitations due to slope or physical or psychological barriers that are associated with the landscape. And then also we need to acknowledge our ecological values, environmental values that we place in the landscape, and how much forage is actually available to livestock within these complex landscapes is essentially what can they access to eat, and then including these safe use factors, or these factors that are going to acknowledge our ecological values. And so to determine this, we first need to determine our initial land base that we're going to use, and that's based on distance to water. That's what our first assumption is, and then we're going to express the forage in kilograms per hectare on that, and we can use that information to calculate the carrying capacity once we've assigned a value to each individual polygon. So a polygon could be your entire range unit, like the bottom right. All of the range, or all of the buffer lines have been removed, and it just shows that range area that's accessible to livestock based on distance to water. So that's everything that's within 1.5 kilometers of reliable water. Or we can express it in the upper map our polygon can be considered each one of those circles, and then we would calculate the forage within each one of those circles as opposed to the range unit as a total. And there's different reasons why we would use these different strategies, either the range unit as a whole or the individual buffer zones. And so this is the spreadsheet that I generally use for calculating carrying capacity. And I guess the reason why I like it is because it allows for there's a lot of information that can be put into here. It allows for inputs on forage type, estimates of productivity. It includes limitations for slope, access, Rangeland Health. It includes a safe use factor. And then at the end, it provides a water requirement. So how much water is required based on how much forage is available if we were to stock that specific polygon to what is available for forage, how much water is needed to service that number of livestock. So we're going to get it. I'll go through kind of the spreadsheet in quite a bit of detail. So just line by line, we'll go through it. But before getting into it, I'll go through kind of the start of it. How do we estimate the forage production? And that's kind of the base for calculating everything that goes into the table. So the first thing we need to know is we need to know what our forage category is or what our plant community might be. And then we need to assign a value to that. And then we will determine the area that's associated with that forage category, and then that'll provide us with our kilograms of forage over the polygon or over the land base. So there's a number of uses or reasons why we would calculate our forage resource, and one of them would be just to what is our forage resource, how much is on a range unit. So what is the overall forage available without any extra water developments, just the way that it is. What is our carrying capacity, or what is our current forage resource? Another reason why we'd want to look at it is what are our future forage resources based on high resilience ponds. So we could calculate forage based on all water today, and then we could recalculate it based on just using water that's considered resilient, so those ponds that are over 5 hectares in the future, and then we could have a comparison to see what our change in forage is going to be within the current climate scenarios or the future climate scenarios. And then we could also use the same concepts to how can we adapt, how can we use our adaptation, or how can we adapt to the future climate by adding water resources, and what is that going to mean in terms of the forage supply, or increasing or decreasing the forage supply. And so we could put these polygons or these buffer zones on potential locations where water developments might provide access to a different region of the range unit, and then we can recalculate our carrying capacity or our forage resource based on investing in the range unit. So generally what you need is a separate forage calculation for each circle to do that. So for each buffer zone and off of each pond to do that. But you can also add all the forage categories together, and come up with a less complicated spreadsheet, I guess, for depending on what your needs are. So what we need to do to calculate this is we need to stratify. So we'd stratify our landscape into forage categories. Right now, if you look at the bottom left map, there's a lot of white on that map, and there's a lot of unknowns in terms of our forage resource on that map. If we look at the map on the right, we have a fairly detailed forage inventory of that area, and so we have more certainty in what our forage resources are, and what our polygons or what the different parts of the landscape are in terms of their forage type. And same with the top zone. So we have, or the top map. So we have a lot less white in the landscape. There's been a lot more work done in terms of calculating collecting information for forage, like destructive sampling or our range types have more certainty in those areas, and so we're able to create a better map. So the stronger our map is, the stronger our information that goes into the spreadsheet is. And so if we have these maps that there's a lot of white space in them, then that just lets us know that we need to do more work in terms of developing a forage inventory for that region in order to have a more complete and a more detailed calculation. And so we can also estimate forage or estimate area based on just a visual estimation of area, I guess, by just looking at these maps. But we can also do this with GIS. And so either way, I'll kind of go through this a little bit, but either way, we can complete this forage table as like a tailgate exercise where you just print off the spreadsheet, or you have it on your computer. You can type in some estimates, and you can get a start on what your forage resources are, or you can take the information back to the office and use a little bit more detail to plug it into a GIS and get more exact numbers with your area for the different forage categories. And so both options are available, and I've used both for calculating carrying capacity, both just a visual estimate as well as a GIS, more an exact measurement of area. So to estimate area, what we know is the area of a 1.5 kilometer radius circle is approximately 700 hectares, and the radius of a 3 kilometer, and the area of a 3 kilometer radius is about 2,800 hectares. So that's the base of our area from a water resource. And so from there, we can estimate our forage category based on a visual estimate. Like if there's if the dark green is in the lower right map is open range, then our estimate would be, there's about 60% open range on that area, and within 1.5 kilometers of a reliable water resource. And so our area is 60% of 700 hectares, which is, I guess, probably around 400 hectares, maybe a little bit more than that. And so that's what our area of that forage category is, and that's what we would use to calculate the total forage available within that. So if we have dark green, light green, and pink for our forage resources, we would calculate we would estimate the area for each of those three forage types, and then that would base our forage resource from that water source. And if we go and make an assumption that that livestock will travel up to 3 kilometers from that forage resource, then we would increase that area that we use in the calculation accordingly. And so this estimate can be done with the GIS, or it can be estimated visually, similar to the way that you would estimate canopy closure in a forest, or if you're doing species composition work where you're looking down at a quadrat to estimate species composition. It's the same concept where you're just estimating the percentage cover within a polygon. And so, like I mentioned, unfortunately, we don't have great maps for every range unit. And so on the provincial scale and district scale, we generally would default to the range vegetation inventory. But on the range unit scale, if we're just looking at specific range unit, then we can start getting better estimates using the range vegetation inventory, but then adding your local knowledge of what the different plant types or plant community types or forage types are there. And then we can also do some field verification, either by sampling or by photo interpretation. So by sampling, I'm talking about destructive, so actually going out and clipping areas. And the photo interpretation tool is going through an inventory of past sampling photos and trying to estimate based on what you see when you walk out there. So you would have a photo book with known values based on destructive clipping photos, and you would be able to flip through that to assist with determining what your forage value is. There's other resources. There's resources available for doing this. There's detailed descriptions of and estimates of forage production on the Range Branch website. They're based on dominant plant community, so dominant tree cover and percentage canopy cover. And there's descriptions as to what those plant communities are on the Range Branch website. So some of this information can be gathered using that resource. Also, then there can be adjustments made based on the seral stage of the plant community, Rangeland Health. But there are quite detailed descriptions available for many of the range categories on the Range Branch website. So if you're interested in doing more of a detailed forage production on range, that's generally one of the first places that you would start. And then sampling for forage production. So there's updated sampling methods, and there's a sampling video that's also available. It's been recently developed for doing just this, for assisting with I guess bolstering the data that we have for these maps. And generally a combination of destructive sampling and estimates are needed for each range unit, because the range units are just so large that to get enough samples, to destructively clip enough samples is very difficult, especially at the district or the provincial scale. But using a combination of the destructive sampling and just I guess windshield estimates is what can be used to improve these forage category maps. And then just a quick kind of, so there's a sampling video that was started in 2019. It's been updated in 2020, and Nancy Elliott from Range Branch can provide you there's a YouTube link to that video. The forage sampling methods were originally developed by folks in Range Branch, and it's generally what's used for the recent forage sampling programs. And it was updated. There's an updated version that's also available. It was completed by the BC Cattlemen's Association. Is also available from Nancy Elliott at Range Branch. And so if you are thinking of going out to do some sampling, another good resource is to contact Nancy ahead of time and kind of discuss what the plan is and come up with a plan. A photo interpretation tool would look like this, and so you require a few different views to get a decent photo interpretation tool. So you need a 2-meter view, and this would be something that you could use if you don't have enough time to do destructive sampling, or it could supplement destructive sampling. So you have your photo interpretation tool that you use on some sites, and then you use destructive sampling on other sites. And the photo interpretation tool can also be helpful for estimating limiting factors. Just by looking through the canopy at a 10-meter distance from a photo pole, gives you a decent idea as to what some of the limiting factors within a plant community or within a landscape are. So if you have those two views, a 2-meter view and a 10-meter view, and if you can somehow supplement it by an aerial view, then that kind of gives you a good sort of background, or a good visual estimate of what is available for forage. And I'm currently working on trying to put together a booklet or a PDF that will be available for folks that will go through different BEC zones and variants, and then show different forage production in different plant communities within those variants. And so that will be another resource that will be available hopefully next year. So once we have a forage category and a productivity, then we can start filling in our spreadsheet to calculate carrying capacity, or to calculate the water requirement based on the number of animal units or animal unit months that are available in terms of the available forage. And so the first thing we would do is we would enter the forage category name. And so, for example, in the map on the right, our open range would be one forage category. There's 6 others that are there as well. And so depending on how many categories you have, that kind of drives how many columns you require in your spreadsheet. And then we would enter the production values from the estimates or from actual sampling. So our forage sampling number would be 1,000, as an example, 1,000 kilograms per hectare as our starting number. And what is the percentage of this landscape that is, so anything that was hashed on that map is not accessible to livestock based on distance to water. So just as an estimate, doing a tailgate calculation, you can say, well, about 20% of that landscape is open range and is in that 1,000 kilogram per hectare forage value. So you would do that for each category in your polygon or in your range unit. If we know the area that's within a certain distance of, so within 1.5 kilometers, and I'm missing a heading, there should be within 3.0 kilometers. And so the reason why the total area, it says 274.5 hectares, the reason why that area is less than 700 hectares is because of, so that we have our water resource there, but then there's either a fence line or a roadway or private land. There's something that's also cut into this buffer and prevented a full access to a full 700 hectares. And so, so that the GIS analysis also assists with some of that. So if we have a fence line that runs through our buffer, obviously the livestock aren't able to access the forage resource on the other side of that fence, or if there's a highway going through it or something along those lines. But the GIS can give us very detailed information. And so, our open range is 244 hectares, 244.8 hectares of this 274, and aspen conifer mix is about 26 hectares, and then roads are approximately 4 hectares. So if we assume that if we have roads in terms of forestry roads or even skid trails or old logging roads going through a range unit, this also allows us to create a forage calculation based on those roadways, which can be an important source of forage in some areas. And so it's good to know how much area of road or trails we have within a range unit as well. And so this can be calculated based on 1.5 kilometers from a reliable water development, and also from or from within 3 kilometers. So if we have the ability to do a GS to estimate the area with it, it can really improve our overall understanding of the forage resource. And so that estimate would go into line 5. So you would put your area within 1.5 kilometers into line 5, and then within that, we also want to look at what is the slope within that buffer zone or within that predicted zone of use, because slope will influence our the livestock's ability to access areas that they're not going to be able to travel as efficiently in sloped landscapes. And so we need to acknowledge that there's a reduction in forage based on slope. And it is very difficult to estimate slope with a map, with either a topographical map or a digital elevation map, or even a map that highlights where our slope is on the landscape. And so if you can do this through a GIS, that's the best way. But also you can still do an estimate and get a fairly reliable estimate of forage based on a visual estimate. It's just everything's a little bit better if we can use the GIS to do that. So this is just an example of a slope, of a map that has the slope on it. And so you can, I guess maybe you can appreciate just like how, if the dark shaded areas are that 30 to, let's see if I can, I believe that is 10 to 30% slope. if we can estimate this using the GIS within those polygons, and that's obviously going to give us a better calculation than if we just estimate it based on a visual estimate. But that said, you could still assign a percentage of 10 to 30% slope based on this map. And it may require a bit of on the ground knowledge as well when dealing with the slope, and also the type of livestock that are being used. Some animals are more willing to travel on slopes than others. So an example how this would look is if you take that open forest within 1.5 kilometers of this water development, and then it breaks down your 0 to 10% slope as being about 120 hectares, your 10 to 30 being about 100 hectares, and then anything that's over 60% slope it's probably completely inaccessible. So that would just be taken out of the forage calculation. And even in some situations, maybe you'd want to take the 30 to 60% slope out of the forage calculation as well. But the spreadsheet allows for that. So if you're able to enter the areas of each slope classification, the spreadsheet will just automatically calculate or deduct that area from the forage calculation, or it'll assign for example, for the 10 to 29% slope, it'll assign a reduction, not 100% reduction, but it'll assign a reduction to it based on either what the manager puts in or guidance from your range practices, which would be the 11 to 30% slope. Generally, we're looking at a 30% reduction in carrying capacity, and up to 60, we're looking at a 60% reduction. And then if we're at slopes greater than 60%, we're probably not getting any grazing out of those areas. Another consideration for calculating available forage is to provide total forage that should be available to livestock, is to provide a value to Rangeland Health and also to seral stage. And so within Rangeland Health, generally that's going to describe what our current state of vegetation is compared with that of the potential vegetation or potential plant community for that site. So it compares it to what would be considered a climax plant community for that site. And if you have poor Rangeland Health, generally you would assign a safe use factor that is a lot less than if you have good or excellent rangeland health. If you have good or excellent rangeland health, generally you don't require an extra deduction for the safe use factor. But if you're in poor or fair rangeland health condition, then you may want to start considering adding a safe use factor, and then that would be in the deduction based on rangeland health, and that would be in the spreadsheet as well. And the Range Branch website, and with the forage category descriptions, it also goes through kind of what that early, mid, late seral plant community looks like, and how the yield or the carrying capacity can be adjusted based on that rangeland health assessment or seral stage. There's other limitations that we would account for, including dense trees, rocky ground, invasive plants, or just ungrazable area, like the base of the juniper bushes there's not much growing in there, so we need to account for how much of the landscape those types of limitations account for. It's important to consider these because they're responsible for limiting what is available for livestock. And once we've considered those limitations, and as well as the rangeland health and seral stage, we can assign a safe use factor. And historically, a safe use factor has been kind of take half, leave half. So whatever forage is available on the landscape, we would only be grazing half of it or allocating half of it to livestock. There's There's more, I guess, recent research in terms of climate change adaptation has suggested that we should be looking more at 35% for our safe use factor in a healthy plant community. And if we have poor range health, then we would go all the way down to only allocating 15% for livestock. But this again, I want to emphasize, this is like a management decision that is based on a range manager's knowledge of the landscape, knowledge of the forage resource, and how much they want to plan for future climate change scenarios. And so on line 19, I have 4 kind of guidances based on Rangeland Health, and also based on considering climate change, but those aren't necessarily set in stone by any stretch of the imagination. If you have tame forage, for example, your use factor would be much higher. You'd be definitely looking at taking 50%. So anyway, those are the things that would go into the limitations and into the calculation. And then what we would get is it would provide the total number of kilograms in that polygon that is available for livestock. And from that, we would be able to calculate our animal unit months, which is the amount of forage that a 454 kilogram cow and calf will consume. And this is another number that is not always used, because oftentimes the average cow-calf pair now is larger. And again, this is if a person's running larger animals, then they would want to adjust that based on the size of the animal. And what this provides us, though, is it provides us the total number of AUMs per hectare for any given polygon. And that's basically what that landscape or what that polygon will support. And so this assists us with providing a carrying capacity, so that can be related to the stocking rate. And then you can add the grazing period. So how many months are the animals on that specific polygon? And then that provides the number of animal units that would be supported for that polygon. And then it will also provide a number for the water use. And when we look at the water requirements, we're basing it on one animal unit consuming, so that cow-calf pair consuming 60 liters of water per day. And this would be for the peak summer requirement, but that's, it's a safer measurement or safer estimation than using a lower number of liters per day. And so we're using the peak water demand for the summer. And so if you have 100 animals using 6,000 liters a day, you're getting about 18,000 or 180,000 liters a month, or 180 cubic meters of water. And if evaporation from a pond I'm going with a pond that's about 4 hectares in size, or 4.5 hectares in size, evaporation from that same pond is about 4,400 cubic meters just for the month of July. And so livestock consumption would be about 0.004% of that of the evaporation in July. And so it just puts into context what livestock are using in terms of drinking water for the time they're on Crown Range. And so this, and based on the amount of forage that's available for a specific water resource. So obviously, if we're looking at feedlots, or looking at someplace where there's higher concentrations of livestock on a small land base, you're looking at much greater water demands. But for a pond, if we're allocating the forage based on the forage calculation, then our water requirement is also allocated based on the available forage that's there. And so it just puts into context, the amount of water in relation to climatic demands that livestock use. And this doesn't account to other. So there's other implications that livestock can have to water that can also increase evaporation, or so there's not always a direct link with what livestock are drinking versus what their implications are on the landscape. And that's also acknowledged by identifying what ponds are at risk. So, and identifying that unimpeded access can lead to this degraded function of riparian areas, and this can impact evaporation. If we reduce all the vegetation around a pond with our management decisions, we're going to increase evaporation. And so it's not just the water that the livestock are drinking, but it's unimpeded access that can also increase evaporation. And then I guess as a side effect, then there's more than the livestock are creating a situation where more evaporation is happening than what would happen if there was a healthy plant community around that riparian zone. But it also puts some emphasis on that there are things that we can do to limit that impact that livestock can have on heavily used ponds. And so recognizing that there's management strategies that can be used to reduce these impacts is also an important thing to consider. So in terms of climate adaptations, we can create our forage budget or our forage calculation on, we can assess different ponds that are at risk in the future but not at risk now, and make comparisons using this method. I'll just go back to, so we can calculate our overall forage production, we can do comparisons, and we can determine the forage resource based on, if we located a water development in a specific spot, we can calculate the forage resource that would be associated with that water development. So that can help with making economic decisions on the landscape. If this water development is costing X number of dollars, how many AUMs is it providing for over the life of that water development? So over a 25-year lifespan of the water development, how many AUMs is it providing for? And so it assists with making some informed decisions around developing resources on the rangelands. And so we can include the Beck maps then into that estimation of forage by looking at the future Beck zones compared to the current Beck zones, and what the forage resource is based on our estimates of forage now and in the future. And then I guess I already went through this part, but just if we have potential for 4 different water developments on this landscape, we could calculate the forage resource at those 4 locations and then make a comparison. Which one do we want to develop if we have limited resources? Darren, did I leave you enough time?
Maybe you want to just move this to the next webinar, Andrew, maybe,
Yes.
rather than powering through, because the remainder of the time might be better used to people asking you questions, to be honest with you.
Yeah, okay, let's do it. We'll do the accessing, ingesting, collecting,
sure,
ingesting,
that sounds good.
At the beginning of next webinar. So so that's kind of I guess a wrap for webinar 3. We're going to go into the actual planning of the 3 pilot projects next on Thursday. And so where we use the concepts that we learned today to actually plan water developments on 3 different range units. So that's what we'll move to next week. So are there any questions from today?
Great, here we go. We got our first question here. Thank you very much. So it appears that the evaporation of water from one pond is approximately 25 times that of a 100-head herd. Is the 25 times an average across the board for consumption?
I would say no. If you have a very high, like if you're looking at a small grassland pond, you would have a very high forage resource and potentially a very small pond. And so that number, you would have much more demand off of a smaller pond with a high forage resource than what you would have off of a larger pond with a small forage resource. So so no, it doesn't. And but recognizing that can assist with which ponds should be the focus of protecting, I guess, in a sense. If we have smaller ponds that have with a high forage resource around them, then we can be quite assured that there's going to be a lot more demand on that water resource, and then the impacts are also potentially higher.
Here's a question that's looking at wildlife, and have forage allocations for wildlife been considered? So for example, looking at elk and what they would require for forage.
Yes, so with the safe use factor, if we use yes, it is in the safe use factor calculation and in the Rangeland Health assessment. So part of the forage allocation of the take half, leave half concept is to leave forage for wildlife, leave plant litter to protect the soil. You know, if we knock that safe use factor down to only 35%, as what is suggested in some climate scenarios, and also recognizing not just wildlife, but not just like large game that are feeding on the forage, but also recognizing the need for plant cover for birds, the need for flowers for pollinators, the need for sites for tick nests, as much as we don't like those, but that type of concept, bringing in not only the requirements for livestock or for wildlife to eat, but also for habitat for some of those, like you know, little brown birds and things like that we don't necessarily, that aren't quite as you know, high profile as what elk are. But so yes, and that should be done at that safe use line within the spreadsheet. So it's up to the manager to kind of decide what's required for other uses.
Great, thank you for providing that more detailed information on what that includes and all the habitat and wildlife considerations. If others have questions, you know, pop them in the chat, put them in the Q&A. Give you a few more minutes here to pose your questions for Andrew. Okay, well, Andrew, maybe this is your chance to give us a preview to what we're going to be seeing next week, or sorry, this Thursday in the final session. Yeah, and you can just wrap up today's session.
Sure. So like I mentioned, we'll go through the pilot projects. There's one east of Williams Lake and one that's west of Alexis Creek, and one that's west of Williams Lake, and so we'll look at the three different projects. Two of them have water developments in place. One is in the planning stages, and so we'll talk a little bit about what was required to get the water developments in place, and also some of the challenges in terms of planning and yeah, there's a little bit about the construction methods. Yeah, but there'll be three kind of real life examples of where the planning process was used. So it'll be a good wrap up to all that we've discussed. So I'm looking forward to it.